For my proposal, I chose to write about the communication and design failures of the 1986 Space Shuttle Challenger disaster. I chose a specific communication design failure because many people just hear a small portion of the story, such as the shuttle blew up 73 seconds into the launch and killed all 7 crew members aboard. But not many people know about the true backstory. In my presentation, I will explain how the deaths of 7 astronauts could have been avoided and the actions that can be taken to prevent a similar disaster from happening in the future. Like I mentioned earlier, we all know the basics with this event. The Challenger shuttle was torn apart midair on January 28, 1986 at 11:39 a.m. There were 7 crew members aboard the flight: Francis Scobie, Michael Smith, Ronald McNair, Ellison Onizuka, Judith Resnick, Gregory Jarvis, and Krista McAuliffe. But not many people have taken the time to understand that the cold weather on that day played a huge role in the tragedy. Even though weather technicians and engineers knew about the low air temperature on the day of the launch, they decided to continue anyways. The estimated minimum air temperature on the day of the launch was 22 degrees Fahrenheit, but during the launch, the air temperature increased to 36 degrees Fahrenheit. So why was air temperature so important? Well, the O-rings, which were rubber sealants found in the joint seal of the solid rocket boosters, had a resiliency that was directly related to temperature. An O-ring that was in a warmer environment could have been compressed easily and could have returned to its original shape much quicker than an O-ring in a colder environment. It is said that the O-rings on launch day were not returning to original position to close the opening of a gap at the time of ignition. So if all of this was known for days or even months before the launch, why did NASA proceed? Morton Thiokol, the company that supplied NASA with the solid rocket boosters, wrote a call for help memo in 1985 trying to inform everyone at NASA of the concerns about the low temperature on launch day and how that would affect the rubber seals. Even with enough evidence, a management decision was made rather than an engineering decision. There were 3 senior managers of Thiokol that made the decision to launch, and as we all know, that decision would later be proven to be a disastrous one. Many engineers regret making the final call to launch. One in particular, Roger Boyes-Jolly, was one of the Thiokol engineers that had originally voted against the launch, but was later convinced that it was safe and the launch should proceed. Even though, deep down, that he knew the crew members of the Challenger would not make it, he decided to go ahead. And that would be a decision that Boyes-Jolly would later regret for the rest of his life. After the incident, NASA began to improve the structural components of their solid rocket boosters. The knowledge that they had gained from their many losses, which include 3 astronauts from Apollo 1, 7 on Columbia, and the 7 from Challenger, will be used to further improve not only the structural design components of their shuttles, but also their communication of vital information that will affect the lives of their astronauts. With lives on the line, NASA has to think about their actions and decisions carefully. Spaceflight is difficult and spaceflight is dangerous, and NASA has gone through a learning process through their many painful losses. The fate of 7 crew members were in the hands of 3 Thiokol engineers who failed to communicate vital information about a structural design flaw. However, 22 years after the tragedy, NASA decided it was time to send a civilian, Barbara Morgan, into space on the 2007 Endeavour shuttle. When making extremely important decisions, paying close attention to details and also trusting gut feelings rather than making decisions based solely for management purposes is vital. There are lives on the line, and NASA has learned from their mistakes, and they have set an example for everyone. Further investigation into the failure and exposing the true cause of it can educate the public and help prevent future catastrophic space disasters from happening. Please approve my proposal for this case study, and thank you for your time.